Hi everybody and welcome to the DevOps-Exchange. This is our fourth virtual event on our very first lunchtime event. So do let me know in the comments how you feel about this, or if you prefer them in the evenings. It's good to get your feedback. Just as a disclaimer, I do have a very large, very loud dog that doesn't like it when she can't see me. So if you hear any commotion in the background, I can assure you no animals were harmed in the making of this meetup. We'll kick things off. So those of you who have never heard DevOps-Exchange before, we are a very large community of over 11,000 members, slowly creeping up to 12,000. We have local meetups in Edinburgh, Manchester, London, Bournemouth, Barcelona, and occasionally in San Francisco. This is ever growing. So if you would like to host or be in charge of a brand new meetup, please do just let us know. What's next? So you can follow us on Twitter at the Docs Hub. And if you do want to interact with us, please do tag us or use the hashtag Docs. We also have a YouTube channel where we'll be sharing all the recordings from the webinar today. It's the DevOps-Exchange. Not only will you be up to date with what's going on with our events, if you could follow these, that also does me a massive favor, as it's kind of my job as the community and marketing manager. On the agenda today, we have three incredible speakers. We have Ádám Sándor from Container Solutions, who will be talking about how GitOps changes everything in CI/CD. We have Gabriel Cismondi talking about compliance versus velocity in enterprise. And then we have Alessandro Di Maria, Unveiling Tesoro, Simplified Secrets Management in Kubernetes with Kapitan and Tesoro. There is a Q&A box along the bottom of your screen throughout speakers' talks, if you just want to submit any questions you might have related to their talks, and we'll run through a few of them at the end. There is also a poll, which I will make live shortly, which is just about getting to know our community, so please do answer that as well. We're not going to go on too much about recruitment, but of course DevOps-Exchange events wouldn't be possible without the sponsorship and organisation from Linux Recruit. If you are interested in growing your team, or you are using this time in lockdown to look for a new opportunity, please do reach out at www.linuxrecruit.co.uk. If you would like to become a speaker, we are planning our events for the rest of the year. Hopefully they will be back in person shortly, but for the time being, virtual is fine. Do just get in touch at hello@devops-exchange.io. We'd love to welcome you aboard. So without further ado, I think we'll kick off for our first speaker. Is everybody ready?
I am.
Hi, Ádám. Do you just want to jump on the screen?
Absolutely. So, there we go. Whoops, that's my second slide. First slide. There we go. All good?
All good.
Awesome. So, hello everybody. Welcome to the meetup and to my talk. My name is Ádám Sándor. I work in Amsterdam for Container Solutions. I'm calling from Amsterdam. As you can see, the knives up there, it's from my kitchen. And yeah, I work as a cloud native architect, so do all kinds of things around cloud native technologies, cloud native transformations. We are a consultancy company, so we help other companies do these things. You can follow me on Twitter under the handle Ádám Sándor. The O is a 0, very clever of me. And today I'm going to be talking about how GitOps changes everything in CI/CD. It's a pretty big title, so let me explain what I mean by this. First things, I would like to do a bit of a shout out to our events team at Container Solutions, who are organizing a lot of cool events. So please check out our website, container-solutions.com/events. There's a lot of cool free events that we do around cloud native, where you can learn a lot without paying money for it, which is great. One interesting thing is we talk a lot about cloud native transformation strategy. We have several events in that space. If you are interested in that stuff too, besides the tech, then it's a really cool place to find. But also there are like Docker trainings and things like that. So let's jump into the talk. My story starts with large German enterprise company, which has been around for a long time and has been really successful in their business. But the times are changing and they feel their old ways of developing software, their old monolithic software stack is just not holding up to the competition anymore. They're really worried about all these new startups and also larger companies transforming themselves into fast delivery and innovative operations. So large German enterprise company looks to cloud computing as the solution to all their problems. And it is not a bad place to start. Cloud computing can help reduce infrastructure costs, will help you build software and deliver software faster. And that is the biggest problem right now for large German enterprise company. They also decide that, yeah, they want to build, they are hurting because of their old monolithic software stack. So they want to build microservices now, and to run those microservices, they would like to go to Kubernetes, which is all very good and well. However, here comes the consultants that they invite to help them with this transformation. And the consultants are warning them that just building software as microservices will not actually solve all their problems. If they don't change the way they deliver the software and they organize their teams, they will just end up building a distributed monolith, which might end up worse than their old monolith. So consultants say they should deliver their applications independently, all these microservices independently each other, do frequent deployments to actually get the benefits of all that good cloud computing. To this, say the people from large German enterprise company that, yeah, sure, but we can't just do that. We have change management processes, we have compliance, we have auditing, and we have really tough security requirements. If we are holding so much data of so many people, if something goes wrong, we will be screwed. So, and this is not an easy problem to solve. How to do continuous delivery while you have all these tough requirements as an enterprise company. But still, we sat down together with the people from large German enterprise company and tried to work out how to go from code to production in a single day using cloud native technologies, while at the same time keeping all the auditing and compliance requirements. And to explain that, let me just quickly explain what I mean by continuous delivery, because there are different takes on this. So most importantly, release often to reduce risk. Deploy most of your releases to production. So basically every build of an application should be a release candidate that if it passes the CI/CD pipeline, it just gets deployed to production. And the CD pipeline looks like this. You release your software, deploy to a test environment, which should be similar to production, test it, deploy to production, and then monitor the software and users can use it. Very simplified. There could be more steps, more environments, but in a gist, this is it. By the way, I'm going pretty fast because I'm doing like a shortened version of the talk, so bear with me here. If we look at the whole picture of CI and CD, basically CI gets you from merging into your main branch, or let's say the master branch in Git, running tests on this branch, building a Docker image from it, pushing to Docker registry, at which point the CD process kicks in, which will deploy to a test environment, test it, and deploy to production if all goes well, or go back in this process to the beginning if some problems are found. If we add, we are talking cloud native today, and the largest cloud native tool right now is Kubernetes. So I'm just going to focus on that, so I don't have to talk in like weird generic language. We're deploying to Kubernetes today. If we add Kubernetes to the CI/CD pipeline, this is how it will look. The deploy to test will deploy to a namespace on a Kubernetes cluster. creating a deployment object and a service object, and possibly all kinds of other objects depending on what the application needs. And then once we promote, we might be deploying to a namespace on the same Kubernetes cluster or on a completely different Kubernetes cluster, but basically the two deployments are completely the same. Now, if we zoom in a bit on how this deployment really works, let's say this is all implemented in a tool like Jenkins or Circle CI or whatever, which can execute these steps one after the other. How does a deployment step look like exactly? Because we are in Kubernetes land, we will have some YAML files. The YAML file will contain a reference to the Docker image which has been built in the CI pipeline. There will be other YAML files possibly describing other objects like a service to expose the ports of the application. And all these YAMLs will be fed into the Kubernetes command line kubectl tool. And kubectl will apply all these YAML files to the Kubernetes API, which will start, when these objects change in the API, that will kick off the Kubernetes controllers, which will make the actual changes happen. For example, pulling the container image into the cluster and starting it up, which is our the main thing we usually want to get done during an application deployment. So these YAML files that we are applying to the cluster contain all kinds of information, like how many replicas of the application do we want to run, and most importantly, what image. So here I have app1 version 114.2. I'm incrementing this version every time I'm releasing the application. And in my service, I'm saying I'm exposing port 80 of the application to other services to connect to it. What is really important about these YAML files is not all the labels and details in here, but that they are declarative. If we go back to here, we see we apply these YAMLs. We are not saying to Kubernetes that we want to, that Kubernetes, please download an image, Kubernetes, please start up the image, Kubernetes, if that didn't work, do this, do that, try catch, whatever. No, we only tell Kubernetes, this is what we want to happen, and it's Kubernetes' job to make it happen. Not always, of course, can it actually make it happen, but I don't have time to go into that. Now, what really is GitOps? GitOps is a really simple concept with some really far-reaching implications. And this is why I'm coming to the point of how it really changes a lot of stuff in CI/CD. GitOps basically means to put these YAML files that I have described before a slide earlier into Git. Once these files are stored in Git, every change to these files will go through Git. And whatever is running kubectl apply will be listening to changes on this Git repo. So you can already see how you can just chuck this into a Jenkins pipeline, and whenever this Git repo changes, you run kubectl apply on all the files in the Git repo. Nice thing is, you don't even have to care which files changed, because that is Kubernetes' job to know whether an object actually needs changing or whether it has not really changed from its previous deployment. So if we look at the full picture with the CI/CD pipeline, basically what happens is we release the application, compile it, build a Docker image, push the Docker image to the registry, which is up here. There isn't a line there, but never mind that. From this push to the registry actually goes there. And then the next step is in this pipeline basically doesn't finish with either not doing anything, or also it doesn't finish with just launching another Jenkins pipeline, let's say. It finishes with updating the YAML file in the Git repo. So basically, we now are separating the CD process from the CI process by putting a Git repo in the middle. The deployment will happen because this Git repo has changed, And whatever is here, whatever happens here on the right side doesn't care anymore what happens in the left side. This might be Jenkins, this might be on the right side, the deployment might, kubectl apply might be run by something completely different. The Git repo is sitting in between and acting as the real source of truth for changing anything on the cluster. This is the essence of GitOps. So whenever a version change is happening, you can see in red now, the pipeline will, if we want an automated deployment, then the pipeline will have to actually update this YAML file. Alternatively, you can update this YAML file manually for a manually initiated deployment. Now, to how we can use this to actually have safe and compliance approved and secure deployments to production. How we can achieve that is by and also separating operations from development. This was the big thing for large German enterprise company. Developers should not be able to deploy to production. Only operations personnel can apply changes to production. And this was where GitOps really helped us solve this problem, but without introducing some heavy change management software into this process. And the simple solution is, with GitOps, you can simply say that developers will be creating a pull request on the production environment Git repo, on the Git repo which represents the intended state of the production environment. And then operations people are the ones who are responsible for approving pull requests to this Git repo. And thus, we have a nice change management process that only requires Git and pull requests. So we really make this process happen with tools which are familiar to developers, and these days should also be familiar to operations. So here is that process with red font. Never mind. So what did we gain by this? We have a change log of all the changes that are happening to an environment. We can add in the commit message a description of who is making the change and why. We have a review process. We have user access control, because only people who have access to that to merge PRs on that Git repo can now update production. And we have a central source of truth for intended state. These are really, really important things in an enterprise environment, and we get them all out just by using Git in the middle of the CI/CD process. If we look at the larger enterprise picture, then it's the same thing, but looks a bit more interesting, how we change basically the whole enterprise picture. On the left side here, there are development teams, all pushing their microservices through their CI pipelines, all making commits into Git repos, which are hosted, in our case, in Bitbucket. There is the ops team who can merge these pull requests to initiate changes on Kubernetes clusters. And where are these Kubernetes clusters? They can live in actually different data centers. So GitOps also helps with managing a large distributed infrastructure. Each data center can have actually multiple Kubernetes clusters. And on each Kubernetes cluster, there is an agent running, which is monitoring the Git repos, which are related to environments on that Kubernetes cluster. And whenever those Git repos change, this agent will apply the changes to the actual cluster. So at this point, we are managing our whole enterprise infrastructure, multiple data centers, only through Bitbucket, only through pull requests in Git. Everything becomes much more distributed and simple. What's in those Git repos? basically either Kubernetes manifest YAMLs, they can be Helm charts, they can be pointers to Helm charts which are in a chart repository. They could be customized files. There can be basically whatever, as long as it's declarative configuration, because one thing you don't want to be dealing with is what changed from compared to the previous version and how did it really change. That's something you want Kubernetes to be dealing with. How does that synchronization happen? I mentioned here that we have an agent here. I don't have time to really explain. I have a few slides explaining this in detail, but in 20 minutes, I'm not able to do that. So let me just say, it can be a CI pipeline running like a Jenkins running on the cluster, running a script which runs kubectl apply. It can be Flux from vworks, which is a tool which runs in a single namespace and applies configuration to that namespace. So you'd have multiple Fluxes monitoring Git repos. There is Argo CD, which monitors multiple Git repos and applies them to a cluster. And then there is Jenkins X, which is a tool that does the whole CI/CD process, everything around it, and does it in a GitOps way. So that one is a really complex tool. I'll get back to it in a moment. Which Git provider should you use? Any of them, basically. All of them, they need to support pull requests. That's the important thing, and every Git provider supports pull requests, so you'll be fine whatever you pick. And how to get started with GitOps? Here I'm coming back to Jenkins X. Jenkins X is a tool which really sets up everything for you. A lot of different tools, including the Git repos. It sets up for you and configures them in a way that the whole GitOps pipeline from code to deployment to different environments will just work. So I don't necessarily know whether Jenkins X is the best tool to set up for the production environments, but Jenkins X is a really good tool to get started with playing around with GitOps. Actually, it was the inspiration for the system that we set up with large German enterprise company. So to reiterate, in the new GitOps world, Git is at the center of everything that happens in your data centers, and it covers all your corners with regards to compliance, security, audit, etc. And so with this, large German enterprise company is a little bit closer to the clouds. Thank you. Once again, please check out our events page and let me know if you have any questions. Also, here is a tiny URL link to some blog posts that I wrote about GitOps and also this specific project.
Okay, thank you. I think we do have one question in the Q&A. It says, I wonder if you can scan images for vulnerabilities in the pipeline before pushing it to the registry.
Yes. Well, basically GitOps doesn't do, simple answer. GitOps doesn't change your CI pipeline. So anything that happens before pushing to the registry GitOps doesn't have any effect on that really.
Okay, brilliant. So if anyone has any further questions, they can pop them in the Q&A. If you just want to stick around and maybe answer them during the next talk, if they're specific to you, that would be great. Okay, up next.
Thank you everyone for listening.
Brilliant. Up next we have Gabriel. Are you with us?
Yeah, I'm with you. Sorry for being late. There was a bit of trouble connecting, but I'm here now.
Brilliant. Do you want to just share your screen and get started?
Yeah, sure.
Excellent.
Cool. Should see it. Can you see the screen?
Yeah, all good.
Okay, great. Well, first of all, thanks for having me, and also very nice, the first talk. I hope, we all get into GitOps very soon, although I'm not sure it's going to be that easy for everyone. My name is Gabriel Cismondi, and I'm going to be talking about compliance and velocity in the enterprise. So actually, kind of close to the first talk in a way. So a bit about myself. I've been working in the last few years mainly with scale-ups and fast-paced environments, and I recently, roughly 1 year ago, joined HSBC because I kind of wanted to help them through their move to the cloud. So there's a lot of challenges in there, and I'm very passionate about, kind of trying to solve problems at scale. So what is compliance? I guess, we all know what compliance is, but I just wanted to touch on that because, it's very important to understand that compliance is nothing more than just, satisfying certain requirements. And there are many types of requirements really that can come from, regulations, security, especially when it comes to, cloud and infrastructure. Those can be around, infrastructure security, application security, infrastructure patterns to protect what we do, data protection, and all those kind of things. So, being compliant just means we satisfy the requirements, and we, with those requirements, we are sure that we're managing risk in the proper way. So, what's velocity instead? Velocity is speed and direction. So basically, as a company, when we have a roadmap and we want to deliver against that roadmap, the speed we have in delivering certain features and in achieving certain milestones, that's what we can consider as velocity. So it's not big news that velocity hasn't been the most important thing for big enterprises in the past, because they tend to have kind of a slightly different approach when we think compared to startups. But it's increasingly becoming an important thing, because we are seeing every day disrupting startups that are leveraging technology and their kind of freedom in building and doing things very fast, and those startups eventually get big, and they are threatening many of the big companies we're working with. If we think about, for example, healthcare or also insurance is a very good example. Many small companies are now kind of pushing very hard in that sector. So velocity is becoming increasingly important. So unfortunately, what we tend to see is that the bigger the risk, the lower the velocity is. And when I think about risk in this case, is not just security risk or data loss risk or things like that, but also I factor in complexity as well, because the bigger a company is, the easier it is to have a very big blast radius if we do something wrong. So working in a complex environment with complex infrastructure and very complex application is also part of the risk. So, but why is that? Why is that velocity is impacted by risk? What's the problem in all this process? This is something that's very interesting for me. The whole thing between the comparison between small companies and enterprises, and what I found in the past is that generally, when you're in a startup, you have a very easy way, ideally, using GitOps or any other continuous integration technique. But you have an idea, you develop, you build, it works, you deploy. Maybe you test, not always, but something gets live pretty fast. And I was trying to replicate this kind of workflow for the enterprise, and I just went out of memory really, because when I think about getting something done in a big company, an enterprise company, you have architects boards, you have application design boards, security boards, risk assessment, cloud design, compliance, data governance. In the past, I found also that sometimes you also have to get the approval of someone that's higher up, that's been around the company for a long time, and all of this without even factoring, budgets, execution time, delivery time, deployment process. It's very complicated, really. And now the thing is, it seems terrible, when we look at this list and we think about everything that's involved. Seems very bad, although there's a reason why, and the reason is risk is not going away. So risk needs to be managed and mitigated. And when you think about, for example, companies in healthcare or companies in the financial sector, you don't really want to be giving your money or giving your health data to a company that potentially will move fast and break things. So with this, I just want to clarify that I'm not saying that all startups break things. There are very good startups, they don't break anything. But in general, I'm just saying, the approach of managing risk is very different. So considering the risk is not going away, there's somehow we have to manage it. And what I found and what is going on in many enterprises is that we need to understand that velocity is one of the outcomes we want, not the only one, but one of the outcomes we want. But that's just an outcome. It's not something we can change. We need to instead work on risk management and compliance to make them more adaptive, to make them faster in a way, right? And we can approach the problem with kind of a DevOps mindset, I guess. So what does a DevOps mindset in this context mean? So as always, I kind of tend to analyze the things when it comes to DevOps, breaking them down into 3 cornerstones of DevOps, right? So culture, measurement, and automation. So by the way, I tend to include sharing as a part of culture. So, one of the things that many companies are doing now is, going through their digital transformation journey, trying to become very agile. They're doing a lot to review their processes, internal processes, that big list we've seen before. They're trying to upskill people and unify control functions, although it's not that easy. And that's part of the cultural change, and really there's not much we can do on that side rather than trying to do those things, right? There's no technology helping us. It's really applying practices and changing the way people say things. What is interesting though is that instead in the measurement and the automation side, that's really, those are the 2 layers where technology can help us a lot, and especially the cloud in this case, right? And when I mean cloud, really, having worked with companies that tend to have hybrid kind of architectures, or sometimes multi-cloud architectures, I think about the cloud as everything that can be automated, everything that has APIs, and that can be abstracted in a way. So I'm not talking just about public cloud. So what can we do? There are certain things that we can do, such as, in the measurement space, we can understand what the risks are and define them. First of all, because if we can't measure and if we can't really come up with a structured way to tackle the problem, it's very difficult to improve, right? So understand what risk is and how to measure it. And then, monitor compliance. So are we sticking to all the patterns that we need to comply with so that we can mitigate those risks? And, most important things, and I think this is something where companies are getting better and better, but there's still a lot to do, is, compliance, just approaching the the problem from a DevOps point of view means that compliance is not just for a team or for a bunch of people to look after. It's something that needs to be visible and shareable, and it needs to belong to everyone in the process, to developers, to people in operation. Everyone is an owner of compliance. And on the automation side, there's a bunch of things we can do, which are compliance as code, continuous compliance. We can try to create compliance CI/CD steps, automate remediations, work around notifications and alert. So, all of these things now are very easy to achieve thanks to APIs and everything that the cloud providers are offering us. So I'm gonna touch on a few of those things. So compliance automation, this is something that I think it's very, very important. And I've seen it, coming up many times, and I think it's gonna be definitely one of the areas that are gonna be, again, coming up in the next few years. Is, we have to unpack the whole idea we had of compliance as a, we thought of compliance as a big monster. It's something that we have to before and after check and make sure that we're okay, and that's why we have all those processes in the middle, right? Instead, if we unpack compliance and we try to integrate compliance at every single step in our CI/CD pipelines, that makes things much easier, because suddenly compliance is not like a big monster, but it's something that can be done in a very small step. And to give you an example, this is one of the things. This actually, I've seen it working, and I think it's fantastic. Having libraries that, for example, integrate all you need from a compliance perspective, and abstract it from the developer and give to the developer or to the DevOps engineer or to the operation people just the tool that you can easily use and integrate in your pipelines. It's very powerful. In this case, I've kind of abstracted. This is some pseudocode, of course, but when you're building a container image, something as simple as building an image, in the background could be doing much more. Could be building the image from the Docker file, scanning it, in case of success or failure, notify the pipeline, to continue or to stop, but also all that attached to an audit service that it's auditing the whole process step by step. So that's pretty powerful, and it's such a simple thing that many of you might be thinking that yes, this is a small thing, and it is, but can be a game changer when you apply this type of philosophy to any one of the steps inside your work process. So another thing is, and again, that this might seem a very, very simple thing, but I've been working with companies in the past that had really bad management of user accounts and permissions, and we ended up in very weird situations in which you don't really want to be. So I think now all the platforms are giving us all the tools to manage things at scale in a standard way, and we have to centrally manage our accounts, define all the permissions based on roles, and everything needs to be as code. It's almost silly to say it, but it's very important. And manage users in a way that's always the same. Now, I wanted to, I'm not sure you can see my screen. So one thing I wanted to touch on, I'm not sure if you've seen AWS organizations, for example. I'm sorry if I mention AWS, but that's where I have the most experience. So AWS organization is one very it's very easy to create accounts that are in a certain hierarchy. I've already done this before, so we don't have to go through the whole process, but I have my root account here. I created a secondary account. You can attach certain policies to that account, which is pretty important. In this case, for example, I have a full access policy and a test policy. The secondary account has been given just the test policy. Let me just double check. Yeah, correct. So this test policy, for example, is just giving access to Cert Manager in AWS. So if I log in the other account, which I already did, of course, and I try to access resources, you can see I have a bunch of permissions errors for all the resources I try to access. And when I go to the resource that's allowed, then I can work on that. So so that's a very simple thing, but very important thing, very powerful thing that we need to make sure we do. And that's just one thing we can do in the cloud, but then we have more important things or equally important things such as compliance as code and continuous compliance, which means we don't think of compliance as something that needs to be reviewed by a human, but it's actually a set of rules that we can write, that we can effectively write as anything else, as as our infrastructure, as our applications. We can write our compliance rules. We can create auto remediation actions for those rules. We can define when and who and what to notify on, and also define what acceptance looks like. So if having a low risk compliant breach is acceptable for a week, then that's fine. We can, the most important thing, as I was saying before, we can measure it and we can decide what to do with it. And then, again, make compliance accessible to everyone through dashboard. I wanna touch again, I'm almost at the end of my presentation. So I wanna touch on one of these things, for example, and I'm sorry, couldn't show more, but I've configured, let me go to my browser before. So in my AWS account, I'm using, by the way, can you all see the screen well? Should I make it bigger? All right, so I've defined a rule, for example, in my config account, which is a very simple rule. As I was saying before, the fact that these rules are, we can apply them and write them as a code is very, very important, because it means we can replicate them very easily. I can, and at every moment in time, just see what my rules are from a code point of view. This is the same rule that we were looking at, but through the console. And this rule is a very, very simple rule that basically is scanning my images and is showing if there is anything that's non-compliant. For this rule, I have specified a certain IMI I want instances to be started from, and I have an instance that's been started from a different IMI. So that means my instance is not compliant. I can, once again, this is very simple to set up, but also very powerful. I can also eventually attach to my rules remediation actions if I want to, even automatic ones. And that's kind of where we want to get, right? That's part of the outcome. So just to close this, the whole presentation, the outcomes of doing this, doing these things is actually, first of all, enabling developers to be more free, but in a controlled space, because we know, we're in a high risk environment, so we don't want them to do everything they want. We can start seeing compliance as a living thing, as I was showing, we spin up an instance and we can see straight away if it's compliant or if it's not compliant. We can mitigate risk in a way that's replicable, so we can do it the same way for every account we spin up, for every resource we create, because it's code and, you know, it's version, you know, it's replicable. So we can reduce the amount of, you know, processes and the steps that are controlled by humans in those processes, which is very important, because that really makes things much faster. Eventually takes away some of those points in the bullet list I've showed before. And, you know, at the end, what it does really, all this approach to compliance, it really does increase velocity, because effectively takes away some of the manual work and makes things easier, and we can approach them in a more agile way. And I think that's it. So thanks a lot. I'll go back to the first page, because there were my Twitter account and my LinkedIn account if you want to connect. And if you have any question.
Yep, so we've got a few questions in the Q&A. The first one is, how would you describe the security of data on the platform? I'm
not sure I understand the question, but, you know, I can try to answer that. So data lives, as everything else, lives in certain resources, whether they are you know, volumes in the cloud or anything else. And even for those objects, you know, we can apply a set of rules that you want to check on. Of course, we want to make sure that everything on those drives is encrypted, for example, and, you know, we can check that. If it's something is not encrypted, it's going to show up as non-compliant. Or, you know, we can also manage encryption at rest and in transit, and everything is really, once again, we can monitor it through compliance rules.
Okay, brilliant. And then Claudio has said, how do you think the several bank boards you mentioned should integrate in order to speed up the pipeline for speed from a process perspective?
That's a very interesting one. It's not an easy one, because I think, you know, especially while we're in a migration period, there's still a lot of, you know, on-prem things, and like kind of things that are not in the cloud yet, and there is a bunch of stuff that now is in the cloud. So it's difficult we can't just get rid of some of these steps in the process. But I think what many organizations are trying to do is just, as I was saying before, upskilling people so that they have the whole picture, and they can, so that the process can kind of converge to certain important steps. Also, another thing that's very important is trying to see the whole process from a customer perspective. So it means if I'm a developer or a team, I want to get something in the cloud, rather than having to go individually to each one of the members and follow each one of the steps. I kind of, you know, give my idea, my design, my you know, document what I want to do, and there is this kind of organ that takes care of somehow getting through the process. This is one of the directions I think many companies are taking.
Okay. Brilliant. So we are going to move on to our next talk, but if you have any questions for Gabriel, please do pop them in the Q&A, and if you want to stick around for a little bit and answer them during the next talk, that would be great.
Thank you.
Okay, wonderful. Thank you so much. So we have Alessandro up next. Are you ready?
Yes.
Perfect. Take it away.
So hi everyone. Thank you for joining. My name is Alessandro De Maria. I'm head of SRE at Synthace, a company developing a software for helping biotech companies develop their processes, their biology experiment faster. At DeepMind, which is my previous company, I also helped founded the Kapitan project, which is a tool that helps configuration management of any sort of resources. Mainly, we use it mostly for Kubernetes, which is what this talk would be about. But we can also, and this is also to answer some questions I've seen around, We also use the exact same tool to manage Terraform and other processes that can be like pipelines or Spinnaker or Argo CD or anything in the middle. So really it's quite generic, and I'll try to talk a little bit about it, but I want to focus on kind of another product we've just released through the Kapitan kind of tooling, which is Tesoro, which is going to help you manage secrets end-to-end from where you generate them all the way to where you start using them. So I'll share some presentation now, and I will follow up with a demo so we can see a bit more with a clear example how Tesoro works in this case and how it makes our deployment much more secure and much quicker. So I'll be sharing the presentation now. Hopefully everybody can see it. Let me see if I, okay. So as I said, Tesoro is the last tool we created under the Kapitan project. It's basically a webhook admission controller for secret management. Webhook admission controller, for those who are not aware of how it works, is basically a component you can install on your Kubernetes cluster that will intercept requests to create new configuration of Kubernetes and do something with those requests. So for instance, Istio uses the exact same approach to inject the Istio proxy transparently when you apply a new deployment. We use it for converting Kapitan secrets into the actual content of the secret, so that this kind of decryption happens at a later stage in the cluster, and the secret stays unencrypted for the whole time while it travels to your cluster. So I cannot, unfortunately, introduce Tesoro without first mentioning about Kapitan as a project, because it's a project we've been working on since 2017, and obviously this tool that we developed, Tesoro, is intended to be used together with Kapitan. So Kapitan allows you to create templates for any sort of a configuration, mainly, as I said, mainly Kubernetes objects, but any sort of a configuration file, and allows you to mix and use whichever of these kind of templating engine you prefer. So you can use JSONet, which is like a language for generating JSON and YAML data, Jinja. We can use also help, so we can leverage from libraries, from charts already out there, and allows you to deliver them using Kapitan. And also we can use a tool called a language we developed internally called Cadet, which is based on Python, which allows you to basically do exactly the same, so generate new Kubernetes resources or any other kind of file resources you want to have. So it's usable. It's suitable for anything, starting from Kubernetes configuration to Terraform to Spinnaker, but you could also use it for generating compliance kind of based config files that are used somewhere else, just to follow up on the previous kind of conversation, the previous presentation. We use it also for generating like documentation, so that the documentation that we produce when we create a new resource matches exactly what the actual application we are deploying is like. So you can make playbooks that are specific to a deployment with all the right information that comes directly from that deployment. So in a very short, I mean, I only have 20 minutes, so I'll go as quickly as I can. But ideally, what you have with Kapitan is that you have some data, so a source of truth coming from a structured set of data we call the inventory, and then we pass that data, we compile that data, we create like the inventory for a project, we pass that data through all the different templates And going through those templates makes you generate all the different kind of files that you may want to use for your application or for whatever other configurations you have. Yeah, so to make things a little bit easier, this is also, I think, the last Kapitan thing only that I will mention in this talk. We've gone through the process of creating what we call manifest generators, which means that it's a super quick, super intuitive way of creating new configurations for Kubernetes deployment in this case, by starting from a very, very kind of simple definition inside the inventory. So as you can see here, I will be using this component called the Echo, what I call the Echo server, which is based on this very nice image that it can be found on the Docker Hub. All it does is just start a simple service. But by defining a configuration like this, where I just give it the name of the, let me see if I can put a pointer here. Yes, by defining the name of the component, the image this component will use, env variables or port definition, by defining this kind of configuration on the inventory, the generator using a sort of a universal templating system will generate all the configuration for Kubernetes for me. So to use, because most of you will be probably more familiar with Helm. With Helm, if you have like 20 components, pretty much you need to, even if, especially if they are of different kind of types, with different kind of functionalities, you will end up with 20 different charts. And maintaining all those kind of charts, because it's impossible to share, to sanely share kind of templating features across all of them, will become extremely difficult to manage all of that. So using a generator, Kapitan generator allows you to share lots of the logic of how to generate these charts. It's like literally a universal chart, but just defining the configuration, you actually get the images being produced. So this is as much as I will be saying about Kapitan. For anything else, you can join us in our channel, or you can read the blog, which I will mention after. The only thing what I want to talk now is about how we solve also the problem of secret management. So other solutions out there don't have a native way of dealing with how you store secrets in your configuration or in your kind of within your deployments. So most of the time, especially I think with Helm, which I'm not enormously expert on because clearly I don't use it. But I think you rely on third-party tools like Gitcrypt. I think some people using Gitcrypt or Vault, perhaps to store some part of the secrets that you want to keep within your deployment to follow your deployment. Kapitan, on the other hand, offers you a first-class support for what we call references, because the use we have is a bit more generic. But in practice, is basically most of the time we use it to store secret content, so like a password, a certificate, or so on. So the way it works is that you would define secret with the following syntax. You would choose the backend you want your secret to be kind of encrypted or stored against. You would define a path for a reference, like a file reference for the secret you want, like an identification for the secret you want to handle. And then you can pass some functions, which I will explain in a second what these functions are. So starting from the backends, you can already see that it gives you a very good kind of a set of features straight out of the box. So you can use the plain backend, which is very helpful during kind of just a demo, so just for inserting kind of values that are where you just want to decouple that value, but it's not actually a true secret. Base64, same as plain, and then you have like proper encryption, kind of proper kind of secure storage. Like you can use Google KMS, AWS KMS, you can use Vault, or in a particular situation, you might decide to just use plain old GPG for encrypting your secrets. Functions, on the other hand, which is something that you add after the definition of your secret tag, gives you the opportunity to somehow auto-generate secrets in some situation where if you just want a password, you actually don't want to generate it on www.password.com and then cut and paste into your terminal. You just want Kapitan to generate a secure password for you and store it. So literally, you will never ever see that password until you actually have to reveal it for some other reason. Greatly simplifying the process of bootstrapping kind of new configurations, because you can embed the instruction of how to create the secret right into the definition, in this case, secret definition. So here is a couple of examples. In the definition of a component, I could say that I want a base64 type of secret, which I repeat, it's not a secret per se. In this case, it's just a reference, an external reference to a value. We can use a path, which is, it can be a path that is specific to the target we are operating within, and then the ID for the secret. So in this case, just two random secret, one called password and one called JKMS secret. The functions on the end, random string, allows me to bootstrap the content of a secret by providing basically a random string for me, so like a random password. And then the base64 instructions at the end allows me to convert that into a base64 type of secret in case I want to embed it directly into the secret, into a secret object, or if it needs to go through some other kind of processing. And as you can see here in the first part, I can use base64 or JKMS, so I can even mix different kind of backend configurations for secrets, depending on how the specific project I'm working on requires it. Another use that you can do with Kapitan secrets is that you can actually create the secret content by feeding a file directly from the command line. So in this case, I'm generating a secret called GKMS my secret, and I'm passing a file as a reference, and I say that I want this file to be base64 encrypted again. This is the command I ran earlier today to convert a Google service account file into a secret, so that I could make it available for the rest of the demo, so you will be able to see this in action. And you can see more, you can read more about Kapitan and about secrets in the Kapitan blog. I think I've gone as fast as I could, and I think I can get to finally talk about Tesoro. So Tesoro is as I said, a web hook for Kubernetes that intercepts the request to generate a new secret and transparently replaces your secret tags with the actual content that you supply. So if you are familiar with sealed secrets from Bitnami, I think, with sealed secret, the approach is exactly the same. And in fact, I've been using a sealed secret up until Tesoro was available. The difference in this case is that, first of all, it's compatible with Kapitan, so it's much more convenient for me to use Tesoro natively rather than having to go through the conversion step from the Kapitan generated secrets back into sealed secret. But it also has the advantage of including GKMS and AWS KMS, which is not, as far as I know, available on sealed secret yet. Not for any technical challenges, just I think the progress of the project hasn't gone there yet. Same thing as sealed secret, it decrypts the secret directly in the cluster, so it's exactly the same approach. The main difference here is that while sealed secret take a sealed secret kind of type of object, converts into a secret, we actually do it transparently to any kind of Kubernetes object that have specific labels enabled. So we can support handling a secret baked into a config map or directly into a deployment. So this is, I think, is quite fascinating, because it means that in some cases where you have unfortunately have to have a config map with inside a specific kind of secret that is very difficult because your application perhaps doesn't accept it taken from anywhere else. Tesoro can help you there, because it will translate that config map right directly into as it goes through the Kubernetes API, will be turned into into the actual secret. Huge improvement is the fact that your CI/CD software doesn't need to know the key to decrypt these secrets, and doesn't need to know Tesoro is actually installed there at all. So it's completely transparent to your processes, and it can be integrated with anything you have out there. This is another huge improvement over other solution, because, for instance, we're using Spinnaker. Spinnaker does not natively support secrets, sealed secrets objects. So it's a bit more difficult to integrate. We had to do lots of work to make sure that the secret versioning feature that normally Spinnaker would have would work also on sealed secret, while Tesoro basically works transparently in this case. This is basically explaining how the decryption work. I think I said it already a little bit. But basically, you would have the compiled manifest, which embed inside this manifest, you embed the encrypted form of your secret. And as you send them to your Kubernetes cluster, your Tesoro kind of controller will decrypt it and create the actual resource that you are interested in. If there is an integration with the KMS, in this case, this is the symbol of the Google KMS, Tesoro will talk to the Google KMS. It will be the only component that technically needs to have access to your secret, will fetch the key, and will use it to decrypt your secrets. Same would work with AWS and with Vault, with any other supported backend that we have, with more coming every day, every month. The other option, which is what we were doing up until Tesoro was available, is that you still have the option to decrypt secrets by using the normal Kapitan reveal flow. So the Kapitan tool, provided you have access to the KMS secrets through your Google credentials, you will be able to decrypt it while you are applying, so just a bit before it gets pushed to the API. But this would mean that your the people operating with this kind of components would, or even your CI, would need to have access to the secret. So by using Tesoro, you're actually shifting that kind of responsibility to something that is on the cluster, which is meant to be a bit more secure than 20 laptops from all your team members. I'll try to understand how are we with time. I don't know if somebody can give me a hint how much time I have, and I will basically start the kind of little demo that I have prepared for today. So here is, I'm using just a Git repo, Kapitan reference that you can download from the KapiCorp Git repository. And what I'm going to do is show you a very basic example of what happens when you operate with Kapitan. So if I run Kapitan compile, what it does, this is in this case, it won't produce anything particularly exciting, but it's useful to show you in this kind of configuration how many example kind of targets we have configured. So targets is a way to define the main configuration for your Kapitan deployment that you want to deal with. So you can see that we have one target called KapiCorp Tesoro, and then we will have another one called example tutorial, which is the other one I will be using today. If you open the file that defines how these example are meant to be deployed, and if I open the Tesoro configuration, I can see the configuration here is very basic. You will not be able to get it by just looking at it right now, because it's unfortunately requires you to understand how Kapitan works. But in essence, what we are doing here is that I say that I want to deploy the component called KapiCorp Tesoro onto a local cluster, which is of type kind. So this is just a way for me to refer to configurations this way. So if I now want to operate on that specific compile file, if I look at the compile file here under the Tesoro definition.
Hi, Alessandro, sorry to interrupt. I don't think we can see your demo screen, I'm afraid.
Oh, okay. Wait a second. Just give me a second. Okay, I'll have to start again unless you can understand exactly. Can you see it now?
Yep, perfect.
How am I with time? Do I have time or?
Yeah, we've still got a few people that are tuned in that haven't had to rush back to the remote working. So yeah, do your demo. Okay,
fair enough. So sorry for that. I'll go through that again. So if I run Kapitan compile, here I can see that Kapitan goes through all my configurations and recompiles them. This is a fully GitOps. So whatever you've seen before, Kapitan is the right tool that you need to allow you to achieve your GitOps setup. What happens is when I run a compile, it generates files into the compiled folder, which you can see here. These are all the files that get generated by all the different kind of targets I have defined. So in specific, we are going to look at the one generated by the Tesoro target, which is here is basically the manifest, the documentation, and other kind of scripts that are supporting this deployment. And we will look at the tutorial one, which is pretty much the same. I'm using here the Echo server as an example to deploy onto the cluster. So I have deployed a local kind cluster. So this is a Kubernetes in Docker kind of setup. So if I now run, and this is the process that we'll be able to do pretty much everywhere. The approach is always the same. If I run Tesoro scripts apply, what here happens is that the script apply will inject the configuration for Tesoro right into the cluster that I have defined, my kind cluster, which is something that I could show you how to set it up from scratch, but I don't think I want to go through all that. It just takes a little bit of time. By running this command, I've deployed Tesoro on my cluster. I can now do exactly the same by running the tutorial scripts apply. As you can see, I don't have to actually specify where to change my context. I don't have to know where the cluster is. I don't need to know whether the cluster is a kind cluster or is an actual GKE cluster. The Kapitan allows me to hide all that complexity, and by just running apply again, hopefully, the deployment will be pushed to the cluster. I can confirm that by doing kubectl get pods. You will see that I've been lying to you all around because the actual components are already running. But this is if I were to delete the deployment. Do it again. So I can see that pods are terminating. If I were to apply again, you would see that it was just a convenience setup. Now, in the configuration of the Echo server, I defined some secrets. So if you look inventory classes components, which I'm going to the definition of the Echo server itself, you can see here that I have this secret called msecret. And I have it defined as a GKMS type secret that has a random string being generated. So what I would expect now is that by applying the secret, I will be able to see the secret being revealed straight into the deployment. So let's see if that's true. And I will basically, for convenience, edit this pod and try to go to the place where the secret is defined. As you can see, the content of the secret, a randomly generated secret that I had defined in that secret tag, gets automatically extracted and inserted right into the deployment object and up all the way into the pod object. I am not saying that this is the right pattern you should use in this specific case, but it could be helpful in any case, in other cases where you don't want to go through an intermediate secret. Also, the secrets, that was more to show you that this kind of approach works on all sorts of Kubernetes resources, including resources that are not strictly secrets. Secrets will go through exactly the same process. So if you look here, we have an echo server secret, Kubernetes secret, which gets also created automatically and managed by Tesoro, and the content of it will be the decrypted form of whatever we had defined in the secret definition, which is basically this content here that I can see here. Basically, I've created 3 values: encoded secret, better secret, and Google KMS secret, just as a random example. And if we were to get the secret and basically show you the content. Oh, and this is basically the basic C4 version of it. I will not go through the to the decryption of the coding side of things, because I think I'm quite short on time, and be willing to accept questions if you have any.
Okay, let's see. So we have one question saying, Alessandro, do you ever envision Kapitan becoming a Kubernetes CRD? Would this offer the project any benefits?
This is something that I think we've always been extremely strong on not making Kapitan a Kubernetes only kind of a product, because we see the benefit of it in many other kind of areas. So there are people using it for Spinnaker pipelines, people using it for Terraform, and so on. It would depend on what kind of things we're trying to achieve. Tesoro is a first step towards a more cloud-native kind of Kubernetes support. Kubernetes native support, that's what I mean. And there might be cases in which we might want to push a template and have it generated directly on Kubernetes. We are more, we're fond of having everything kind of happening offline, so that enables a much stronger GitOps kind of approach, because the configurations that you see and you store on your Git are exactly what ends up happening on the cluster. There is no CRD magic happening in the middle. I think Tesoro is the only place where we draw a line just to simplify that part of security.
Okay, there is an anonymous question there that I think it might be better if you type a response, but the last question I'd like to read out is, where can I see instructions to install Tesoro?
Yes, so this is the instructions are on the Tesoro GitHub repository. So if you go on Kapicorp Tesoro, I think I will share it later on if there is like a follow-up meeting. But it's on the Kapicorp Tesoro repository, and also if you use the Kapicorp repository, the Kapitan reference repository on Kapicorp, which is where we're trying to bundle all the information and all the best practice for Kapitan and Tesoro, you will be able to find all the instructions there. So you will be able to run a very similar demo to what I've done right now.
Okay, brilliant, thank you. I'm just going to share my screen real quick. Actually, I will just leave this webinar running for the next 5 minutes in case you want to answer any more questions, and then we will be sharing recordings of the webinar along with any links and presentations as early as tomorrow.
Thank you.
Thank you everyone for coming on your lunch. Very much appreciated. This is the first one we have ran at 12:30. So let us know your thoughts on it. Do you prefer it over the evening ones, or would you like to stick to the 5:30 start? And yeah, we'll see you all again soon.
Meanwhile, I'll just take on your offer and reply to the question that was asked before. So the question was, does the reference to the, I'm trying to look for, yeah, is the reference to the KMS key or keyring to use contained in the file source file, like Mozilla SOPs does, or do you need to provide a reference as an external config item? And if so, do all secrets have this to use the same keyring? So the answer is that we to support the Tesoro use case, we actually have provided a very similar approach to what you suggested on Mozilla SOP. So we embed the secret, including the key that refers to that secret, into the compiled file. And you will be able, at the moment, we have a limitation that each target will share the same key. However, within the same target, you might be able to use different backends. But this is something we can easily lift and improve if that is the case. But to give you an idea, it means that you can have a dev target that has access that is encrypted using a key accessible by the developer, and a production cluster that is being used by the production team, or you can go in on a different pattern. But you have a lot of flexibility on how you understand which key to use for each secret. And that's it. And
wonderful. Thank you, Alessandro. I will be shutting the webinar down now, but don't forget to follow us on Twitter at the Docs Hub, and join us on LinkedIn as well to have a look at all the links and resources, and to hear about our events coming up in future. Thanks, everybody.
Thank you.